Hi, it's Mr. Smith, and in this video I'm going to be going over basically 46 through 50, which is everything on systems. We actually got a little further than that in class, but you can always forward to whatever problem you need to go to. So I said I would do a video on what we didn't finish, so that's what I wanted to do. Alright, so first of all, on number 46, it says solve the system using Gauss-Jordan elimination or Gaussian elimination with back substitution. And that's what we did, was Gaussian elimination with back substitution, where we basically put the matrix in row echelon form and then we use back substitution. So in this case, our matrix is 3, 2, 6, 2, -3, -9. And we want to get it into this form where we have ones on the main diagonals, zeros below the ones, and numbers elsewhere. And then once we have it in this form, we can use back substitution to solve the system. Now there's a couple of ways you can do this. We could just divide everything by 3 here. We know we want to start by getting a 1 in this upper left-hand corner. And so that's what we need here. Notice if you did basically 3 minus 2, that would be 1. And then whatever we get when we subtract this row from the first row, we would replace the first row. So basically, we're going to do row 1. And I'm just going to say plus -1 times row 2, and that's going to become the new row 1. Alright, and that'll get us the 1 in the upper left hand corner that we need. So basically, if I make row 2 negative, it would be 3 and -2. Basically, each of these numbers are going to be multiplied by -1 and then we'll add. So 3 and -2 is 1. Actually, let me go ahead and write in the first row because that one doesn't change. Oh, no, I'm sorry, I got this backwards. Row 2 doesn't change, so let's write row 2 in. So we're doing row 1 plus -1 times row 2. So -1 times 2 is -2 added to 3 gives us the 1 that we wanted. -1 times -3 is 3, and when we add to 2 we get 5. And -1 times 9 is 9, and we add that to 6, we get 15. Alright, so now that we have the 1 here, we know we want to use that 1 to get a 0 here. That's what we're shooting for next. And so once we get the 1, we use it to get that 0. So it'll be -2 times row 1. That'll give us -2 here. And when we add it to 2, we'll get 0. So we're going to add that to row 2, and that'll be the new row 2. So let's go ahead and do that. So this time row 1 doesn't change. If you want, you can multiply each of these by -2. This would be -2, -10, and -30. So we're adding 2 and -2, and that would be 0. -10 and -3 is -13. And -30 and -9 is -39. Now, I'm running out of room here, so I'm going to go ahead and put this matrix up here. Alright, so we got the 1 here to start, then the 0 below, and now we go down the main diagonal, and we need a 0 here. And so these are not a 0, but a 1. The easiest way to get that, notice 13 is divisible by 13, and so is -39. We actually need to divide by -13, which we would write as multiplication by the reciprocal. So we're going to do Negative 1/13 times row 2, and that'll be our new row 2. So row 1 doesn't change. Now remember, when we multiply reciprocals, we get 1. We're really just dividing by negative 13. 0 divided by negative 13 is 0. Negative 13 divided by negative 13 is 1, which is what we were wanting. And negative 39 divided by negative 13 is 3. And so you can see now we have the desired form, row echelon form. Now, reduced row echelon form, we would actually use this one to get a 0 here. But we didn't really do that technique in class. We're going to go ahead and translate this to a system of equations. So this will be 1x plus 5y is equal to 15. And we see that y is 3. And so we can plug in 3 for y here. We get x plus 5 times 3 equals 15. X plus 15 equals 15. And if we subtract 15 on both sides, we get x is 0. So far we got an x value of 0. Now I would use, let's see, I'm sorry, we already have y. Y is 3. So 0, 3 is our solution. And again, if we had a choice, we'd probably choose to use elimination here. But what we're doing is we're learning how to use a matrix to solve a system, and then we can take advantage of the technology to do this. If you had to do this problem on the test, you could solve it using your calculator so that when you actually do it by hand, you know what your answer should be, and if you make a mistake, hopefully you can figure out what you did wrong. All right, let's go ahead and do 47 now. So here, I'm going to go ahead and go across. We have 1, negative 1, 1, negative 4, 2, negative 3, 4, negative 15, and 5, 1, negative 2, 12. And what we're shooting for is a matrix that looks like this. So zeros below the ones on the main diagonal, and numbers elsewhere. Alright, so we already have this 1. That's always where we want to start. And then we use it to get 0 below that. And so we'll need to do negative 2 times row 1. Notice that would make this negative 2 so that when we add we get 0. And so we're going to add this to row 2, and we'll replace row 2 with what we get. And let's go ahead and do the same thing for the third row. So here we'll need to multiply by negative 5 times row 1, and we'll add that to row 3, and that'll become the new row 3. So let's go ahead and do that. Now row 1 doesn't change, so let's go ahead and put in row 1. And so I need to multiply by negative 2. I'm just going to go ahead and put negative 2 times 1, and I'll multiply each of these by negative 2. Negative 1 times negative 2, we get 2. Here we'll get negative 2, and negative 2 times negative 4 is 8. So let's add these numbers. Negative 2 and 2 is 0. 2 and negative 3 is negative 1. Negative 2 and 4 is 2. And 8 and negative 15 is negative 7. We'll do the same thing for row 3, but I'm going to erase these and multiply by negative 5. So negative 5 times row 1, we get negative 5. Here we get 5, negative 5, and negative 5 times negative 4 is 20. So negative 5 and negative 5, we get 0. 5 and 1 is 6. Negative 5 and negative 2 is negative 7. and 20 and 12 is 32. Alright, so notice we've got our 1 here with the zeros below. So now we'll move down the main diagonal to the next position. And I need this to be a 1. Well, let's just multiply that row by -1. So -1 times row 2 becomes the new row 2. It's probably the easiest way to get a 1. Actually, I don't see a better way. So we'll just go ahead and rewrite the first row and the last row, because those don't change. And this will become 0, 1, -2, and 7. And so now that we have this one, we want to use it to get a 0 here. So we'll do -6 times row 2, and we're going to add that to row 3, and that'll be the new row 3. Alright, so row 3 is the one that's changing, so we can go ahead and put in the first 2 rows. Alright, so -6 times 0 is 0. Added to 0, we get 0. -6 times 1 is -6. Added to 6 is 0. -6 times -2 is 12. And a -7 is 5. -6 times 7 is -42. -42 and 32 is -10. So we're almost done here. I just need I got my 1 here and then my 0. I got to keep going down the main diagonal, and now I need a 1 here. And so you can see we can divide both of these by 5, and that'll do it. We write that as multiplication by the reciprocal. 1/5 times 5 would be 1. So it's 1/5 times row 3, and that'll be our new row 3. So we have 1, -1, 1, -4, 0, 1, -2, 7. And in our last column, again, notice 1/5 times 0 is still 0. Same thing here. 1/5 times 5, or 5 divided 5 is 1, and -10 divided 5 is -2. So finally, we can write our system of equations now that we have it in. Whoops, and I just realized I was off the grid. So let me just go back for a second. So we just divided everything here by 5, and we got these numbers here. And so now we're going to go up here, and I'm going to write the equations to go along with this system here. So we have 1x minus 1y plus z equals -4. So let me go ahead and move this up here. So x minus y plus z equals -4. We'll have 1y minus 2z equals 7. And z is -2. You can see why they call this back substitution. We're going to plug in the z value here. We'll get y minus 2 times -2 equals 7. That's y plus 4 equals 7. And we'll get y is 3. Just subtract 4 on both sides. And finally, we can use that first equation. We have x minus y plus z is -4. But y is 3. And z is -4. So we're just plugging in y and z into this equation here. And of course, -3 and a -4, this is x minus 7 is -4. We'll add 7 to both sides. We get x is 3. And so our solution is the point, let's see, we said, so x is 3, y is 3, and z is -2. And actually, it looks like I made a mistake here. Hold on a second. What did I do? Oh, I'm looking at the wrong problem here. Oh, I'm sorry, z is -2. That's what I did wrong. Let me fix that. You can see up here we got z is -2. I don't know why I plugged in -4. So this would be x minus 5. Let me just erase this. So x minus 5 is -4. We'll add 5 to both sides, and we get x is 1. And so our final solution is the point 1, 3, -2. Now don't forget, you could put this matrix into your calculator. We talked about how to do that. I'll be doing that on one of the next couple of problems, maybe 2 of them. But you could put this into your calculator and get it in reduced row echelon form, and you would get the same answer. So at the very least, you can check your answer on your calculator. But this is how you would do the problem step by step using row operations. We call this the Gaussian elimination with back substitution. Okay, let's move on. Let me adjust my camera here. All right, and I'm going to go ahead and refocus here. Okay, so it says when solving a system using Gaussian elimination, you end up with the given matrix. What is the solution to the system? So when you look at this one here, notice the second row. What you should notice is to the left of this bar, you have all zeros, and these represent the coefficients for x and y. We're assuming we're using x and y here. So 0x, or 0, plus 0y, or 0, is equal to 7. This is a false statement, and so we know the answer there should be no solution. So that's the easy one. On this one here, we get a row of zeros. What that really indicates is that and I'm sorry, but when we were working with 2 equations and 2 variables, basically it meant we had 2 parallel lines. When we're working with 3 variables, we're now in 3 dimensions, and basically what we have are parallel planes. So think of the whiteboard that I write on in class. That's a plane, goes forever up, forever down, forever left, forever right. And so here we have intersecting planes that intersect at a point, but in this case, the reason why we've got all these zeros is 2 of the equations were actually equivalent, and that just means that actually I said that wrong. In this case, let me think, it's not parallel. Two of the planes are the same plane. That's what I mean. Okay, so let's go ahead and write our answer. So we've said in the past that this means there's infinitely many solutions. However, that's not really all that helpful because we don't even know one of the solutions. And so this is how we write our solutions using what we call a parameter. So we have 1x plus 2y minus 3z is equal to 4. And y plus 4z equals 5. And that's all we've got. Notice it's easy to solve for y here. I'm going to subtract 4z on both sides, and we get y equals negative 4z plus 5. So basically, if I let z be the z value, I'm actually going to say it's just z. I'm going to use one variable for all of these coordinates. Then I know the y value is negative 4z plus 5. And so I just need the x value in terms of z. And so how do I do that? Well, I can use this equation here. I have x plus 2 times y, which we said is equal to this. So we'll plug that in. Notice I don't need to do anything with the z because we're solving in terms of z. And so now I can solve this equation and find x in terms of z. So we'll have x, I'm going to distribute here. I'll get minus 8z plus 10 minus 3z is equal to 4. So I can combine these together. I get x minus 11z plus 10 equals 4. I want to get x by itself, so I'll add 11z to both sides. And I'll subtract 10. And I probably should write this a little different. Let's put the minus 10 here and the plus 11z here. So these guys add to 0. We're left with just x on the left. And then when we add our like terms here, we can only add the 4 and the minus 10. That'll be negative 6. I'm going to put the 11z first, and then 4 and a minus 10 is negative 6. So we'll write minus 6. And so this is how we would write x. It's 11z minus 6. So what we're saying is all our solutions are of this form here, where our parameter is z. In other words, each of these values is written in terms of the variable z. So what if I wanted to write one of the solutions? Now you don't have to do this, but I just want you to see what's going on here. If I choose z to be 0, well, plug 0 in here. Negative 4 times 0 plus 5, that's 5. And plug in 0 here. 11 times 0 minus 6, that's negative 6. And so this is one of our solutions, and you could pick any z value and find other solutions if you wanted to. So all points have this form. Pick a z value and you can find the x and y value that go with that. But this is our final answer here. Instead of saying infinitely many solutions, that's what we would say. All right. So on numbers 49 and 50, the main thing is that you can come up with the system. And in fact, for the homework 4.6 and let's see, what is it? It's I guess it's 3.4 and 3.6 combined. That's an important homework assignment because it gives you some practice coming up with the equations. So hopefully you've had a chance to do that. If not, I would encourage you to do that. But let's see if we can write the equations here. And then with the word problems, you can just go ahead and use your calculator to solve these. All right, so let's get this done here. There were 149 people at a summer camp, including students and camp counselors. If there were 79 more students than camp counselors, how many students and camp counselors attended the camp? So we want to know the number of counselors. And let's see, no, actually they said students first. How many students? We'll call that x, the number of students. And we'll let y be the number of camp counselors. So that's what we're looking for, these two values. Well, there's 149 people at the camp, so some of them are students and the rest are camp counselors. There's an equation there, x plus y equals 149. And then here we have, there were 70 more students than camp counselors. So I think the way I would say this is the number of camp counselors, which is y. Actually, I said that wrong. The number of students. Well, there's 79 more than the number of camp counselors. So if you let y be, well, y is the number of camp counselors. 79 more than that, you would say plus 79. So let's read this and see if it makes sense. The number of students is equal to 79 more than the number of camp counselors. And that makes sense. There should be more students than camp counselors. So in this case, we're going to want to rewrite this equation like this. Now I do want to say we could use substitution, we could use elimination, and this problem is pretty easy to solve using either of those techniques. But you can also use your calculator, and oops, I've got to go run and get mine, so I'll be right back. My apologies. Great. Okay. Let's see if we can get this finished here. Let's see, second quit. All right. So first of all, I'm going to write this as a matrix. And it does need to be in this form because on the left we're going to have our coefficients. So this, in this case, 1, 1, 149, 1, -1, and 79. And then on a test, like on the final when you show your work, I'd want you to write RREF and then write the matrix that you get. And so let's go ahead and do this. So we'll hit second matrix. It's the x to the -1 button. We're going to start by editing. Notice it's on matrix A here. We want to edit the matrix. I already have a 2x3 matrix in here, so I can just hit enter here. And let's put in our numbers. So 1, 1, 149, 1. Now -1, make sure you use the negative button at the bottom here. And 79. And so you want to make sure that your matrix is correct. And it is, so I'll do second quit. I'll do second matrix. And I want to do some math on the matrix. I want to put it in reduced row echelon form. So we'll go down to RREF. Notice there's an REF. We don't want that one. We'll have to do back substitution if we did that. So go ahead and do that. And now notice we need to put in the matrix. So second matrix again. It's on matrix A, so we just hit enter. And you could put in this parenthesis, you don't really have to. And you get your answer matrix. And so we got 1, 0, 114, 0, 1, 35. That means x is 114. Y is 35. So there's 114 students and there's 35 counselors. And if you were taking the test and you want to make sure you did this correct, when you add, you should get 149, and you can verify that 114 plus 35 is 149. And if you let's see, x is 114, that should equal 35 plus 79, and you can verify that that does work. Alright, so again, if you haven't already tried it, you might try to write the equations for number 50, and then I'll show you the solution. Alright, so let's see how you did. So first of all, you have the student has 226 points on 3 tests. The sum of the scores on the first and second test exceeds the score on the third test by 62. The first score exceeds the second by 6. Find the 3 scores. Now, one of the things I didn't mention, but you should be aware of, is if you have 2 equations, or if you're trying to find 2 variables, you're going to need 2 equations in those 2 variables. In this case, you're looking for 3 scores. So you have x, a y, and a z, and so you're going to need 3 equations in the same 3 variables. So in this case, we need to find the 3 test score. So X is the first test score. We'll say Y is the second, and Z is the third. So the sum, or the total for the three tests is 226 points. So that's X plus Y plus Z equals 226. Let's see, the sum of the scores on the first and second tests, so the sum of the scores on the first and the second exceeds the score on the third by 62. So basically, this sum is more than the third test score by 62. So basically 62 more than the third test score. So the third test score is Z, and 62 more than that, we would say plus 62. Now again, I would encourage you to read it again and see if this makes sense. The sum of the scores on the first and second tests exceeds or is 62 more, well, it says it exceeds the score on the third test by 62. So this sum exceeds the score on the third test by 62. Again, another way to say that is this sum is more than the third test by 62, or 62 more than the third test. So again, read that a couple times, make sure that makes sense. I hope that that seems logical. The first score, that's X, exceeds the second by 6. So is basically 6 more than the second. So the first score exceeds the second score by 6. So again, it's basically this score is more than the second test score by 6, or 6 more than the second test. All right, again, I encourage you to read it. Try to be comfortable with that translation. Now, the other problem is we need to put this in the right order. We need our variables on the left. So we're good on the first equation. This will be X plus Y minus Z equals 62. Just subtract Z on both sides. And on the last one, it'll be X minus Y equals 6. Notice in this case, Z is 0. So let's go ahead and draw write the matrix. So it'll be 1, 1, 1, 226, 1, 1, negative 1, 62, 1, negative 1, 0, and 6. And then we'll be using RREF. Let's go ahead and put this matrix in and find our answer matrix. Okay, so let me go ahead and do second matrix. We're going to edit, so we need to go to edit and hit enter. This time it's a 3 by 4 matrix, so 3, enter, 4, enter, and then plug in your numbers. Now for me, I can actually look at my screen right here and just make sure that I put my numbers in correctly. For those of you that maybe have a different, let me do something here. There we go. Your calculator may be one of the older ones, and so you can't see it all, although you can push your arrows to move and see numbers, but I'm going to do second quit. You could actually do second matrix and then just hit enter, enter, and you can see your matrix if you just want to make sure you put in all the numbers right. And now we're ready to do our math and put it into reduced row echelon form. So we'll hit second matrix. We're going to do some math, and so let's go down to RREF, double R, hit enter, and then second matrix, and put in that first matrix A, and There's your answer matrix. So we have 1, 0, 0, 75, 0, 1, 0, 69, 0, 0, 1, 82. So x is 75, y is 69, and z is 82. So I guess we'll just say first, second, and third. So we have 75, 69, and 82. And you can verify that those add up to 226. You can verify that this is equal, and you can verify that this is equal, and check your answers. All right, that's it for the review. If you need anything, just contact me, and I'll do what I can to help.